All right, so in tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over was Q learning, and tonight we're going to pick up where we left off. So to actually see what this formula looks like, here is the approach we'll take with Q learning. We're going to start with Q S of A being equal to 0 for all states. And then every time we take an action A in state S and observe a reward R, we update our value, our estimate for Q S of A. And the idea is that we're going to figure out what the new value estimate is minus what our existing value estimate is. So we have some preconceived notion for what the value is for taking this action in this state. Maybe our expectation is we currently think the value is 10, but then we're going to estimate what we now think it's going to be. Maybe the new value estimate is something like 20. So there's a delta of 10, meaning our new value estimate is 10 points higher than what our current value estimate is. And we have a couple of options here. We need to decide how much we want to adjust our current expectation of what the value is of taking this action in this particular state and what the difference is. How much we add or subtract from our existing notion of how much we expect the value to be is dependent upon parameter alpha, also called the learning rate. And alpha represents, in effect, how much we value new information compared to how much we value old information. An alpha of 1 means we really value new information, that if we have a new estimate, that it doesn't matter what our old estimate is, we are only going to consider our new estimate because we always only want to take in consideration our new information. So the way that works is that if we imagine alpha being 1, well then we're taking the old value of Q, S of A, and then adding 1 times the new value minus the old value, which just leaves us with the new value. So when alpha is 1, all we take into consideration is what our new estimate happens to be. But over time, if we go through a lot of experiences, we already have some existing information. We might have tried taking this action 9 times already, and now we just tried a 10th time. And we don't only want to consider this 10th experience, we also want to consider the fact that our prior 9 experiences, those are meaningful too. And that's the data we don't necessarily want to lose. So the alpha controls that decision, controls how important is the new information. 0 will mean ignore all the new information, just keep the Q value the same, meaning we just keep the old information, ignore all the old stuff. 1 means replace the old information entirely with the new information, and somewhere in between, keep some sort of balance between these two values. We can put this in the equation. We can put this equation a little more formally as well. The old value estimate is our old estimate for what the value is for taking this action in a particular state. That's just Q S of A. Now, we did take a lot more notes, but I'm not going to read everything tonight because it would be a lot to dive into. But we will pick it back up tomorrow. And of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi, and you guys stay Gucci.